welcome back. This is your second video. You are going to be doing this one on your own for the first time. Let's see how you guys do, okay? Um, if you make a mistake, you forget something, don't worry about it. What we'll do is we'll catch you up in class a little bit, okay? So remember, copy down what I highlight, underline, or write down. Okay, you're going to do everything in Cornell style notes. So if you have a word you don't know what it means, you are going to write it off to the side. You're going to highlight it, write the word, find the definition, and put it on the left-hand side of your Cornell notes. Okay, if you have any questions that you need to have for coming to class, you're going to write those down also in the left-hand little column, and you're going to bring them to class. Okay, you're going to write a summary when you're finished. That is what I'm going to check, is your summary. Okay, all right, so are we ready? All right, here we go. All right, our objective is to distinguish among accuracy, precision, and error of measurement. Okay, so measurements, what are they? Well, measurements are a quantity that has both a number and a unit. Okay, here I'm underlining, so what should you do? You should write this down. Okay, fundamental to experimental science must be able to take and evaluate them. Okay, so you need to know how to measure things. Okay, we're going to practice that in class also. But right now, we're going to evaluate measurements. Okay, so accuracy. This is a definition. If I ever give you a definition or a vocabulary word, I definitely want you to write it down. Okay, accuracy is a measure of how close a measurement comes to the actual or true value of whatever is being measured. So this is how close to the actual or true value something is measured. Okay, precision. Okay, measures how close a series of measurements are to one another. So how close they are to one another. Okay, now what does this look like? So after you write this down, and you can pause, you can stop it if I go too fast, write it down. If I go too slow, speed me up. Okay, stop it and pause, come back to it if you have to leave. Just make sure you have all your notes in your summary by the time that your notes are due. Okay, so evaluating measurements, accuracy versus precision. I want you to make drawings. I don't care, they don't have to be this elaborate, but these are targets, okay? So I want you to draw what accuracy versus precision looks like. Okay, so this first one right here, this first one has good accuracy and good precision. Why? All of the darts are clumped together. That is precision. They are all on the target. That is accuracy. Okay, this is what precise and accurate looks like on a target. All right, over here, letter B, we have poor accuracy, but we have good precision. Here, all the darts are clumped together, but they're not near the target. Okay, this has poor accuracy and poor precision. They're all over the place. Okay, what I want you to think about is what would poor precision, and I'm just going to precision, look like if it had good accuracy. Okay, so I want you to draw this. This is going to be letter D. Okay, letter D, I would like for you to think about what would poor precision and good accuracy look like if, or can you even have it? Maybe you can't even have it. But look at your three targets, your three drawings, and try to determine what D is. We'll evaluate it in class, okay? All right, so why is this important? What are some things that you need to know about precision and accuracy? Precision is reproducible. That means we can always get that same marking, okay? Check by repeating measurements. Poor precision results in poor technique, okay? So kind of keep that in mind. Accuracy, is correctness. Check by using a different method. If you continue to get the same measurements every time you do it different ways, then you have a good accuracy. It may not have hit the target, but it's very correct, okay? But if we're hitting our target value every single time, we have good precision. Or and accuracy, or we're hitting the same exact numbers or same exact data every single time, but it may not be accurate. It may be just something else. Okay, we may not have calibrated something. Okay, all right. A lot of times we are going to look for values in the lab that are already known. So when you do this, we must calculate an error. So in lab reports, we're going to be doing this in class as an activity also. Determine your error and your percent error. How do we do this? Okay, to determine error, the acceptable value is the correct value. Okay, they're going to jot that down. Based on a reliable reference. An experimental value is what we do in the lab. Okay, the difference between them, and if you don't know what the word difference means to subtract, sorry, let me finish that tract. I'll try to make this not so long. The experimental value and the acceptable value is called the error. Okay, so I want you to definitely write this formula down. Error equals experimental value minus acceptable value. Okay, let me go back. Okay. To determine percent error is the absolute value of an error divided by the accepted value multiplied by 100. That's the key, 100. Okay, I want you to have this in your journal. Percent error is equal to the error divided by the acceptable value times 100. Okay, so I would like for you to work question 1 to the best of your ability. Okay, and see if you can come up with the answer. Okay, and I want to just see what you come up with. I'm not going to count off if it's wrong. Okay, guys? So bring it to class, write a summary, and I'll see you tomorrow.